In this short video, we will provide some background for our paper using multigraphs to study the interaction between opposition, implication and duality relations in logical squares. When you look at an ordinary logical square, like this one for example, for modal logic, you'll see that the formulas stand in the so-called Aristotelian relations of contradiction, contrariety, subcontrariety and subalternation. For example, necessary P is contrary to impossible P, because these two formulas cannot be true together, but they can be false together. However, these same four formulas also exhibit so-called duality relations. For example, necessary P and impossible P are each other's internal negation, which should be obvious from their syntactic forms. This logical square thus exhibits at the same time both Aristotelian relations and duality relations. Even though these two sets of relations are, conceptually speaking, quite distinct and independent from each other, this co-occurrence is something that we find over and over again in many logical squares. We have been studying this interaction between Aristotelian and duality relations for quite some time. In this paper, we take the next step. We start from a well-known idea, namely the observation that the four Aristotelian relations are actually quite heterogeneous and can be divided into two new and more homogeneous sets of relations, namely the opposition and the implication relations. So instead of studying the interaction of duality with the Aristotelian relations, we now have a far more complex picture. We can study the interaction between duality and opposition, between duality and implication, and also between the opposition and implication relations themselves. To carry out this investigation, we make use of multigraphs. The vertices of such a graph are the individual relations that we are interested in, and an edge between two vertices, that is, between two relations, indicates how often these two relations co-occur with each other in the logical square that we are studying. For example, for our modal square from before, the opposition duality multigraph looks like this. On the left we have the four opposition relations, and on the right we have the four duality relations. And we see that the opposition relation of contradiction, for example, co-occurs twice with the duality relation of external negation, namely on the diagonals of the square. Furthermore, internal negation co-occurs once with contrariety, namely on the upper side of the square, and once with subcontrariety, namely on the lower side of the square. These multigraphs can help us to discover unexpected patterns in the interaction between opposition, implication and duality. This should be quite obvious from the sheer symmetry that we observe in the following multigraph, where we have the duality relations on top, the opposition relations on the left, and the implication relations on the right. In ongoing work, we are investigating what these patterns precisely mean and whether they generalize when we move to larger diagrams and squares, for example, to logical octagons. If you're interested, make sure to check out our paper. Thank you.